This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 2. Bernoulli's equation and continuity, the highest yield topic in Week 2. Get the assumptions and the variable table, and you'll close most fluids problems in under 2 minutes. Here's the problem. Water flows through a horizontal pipe contracting from 6 inches to 3. Upstream velocity 4, gauge pressure 25 psi, frictionless. Find the downstream pressure. By the end, you'll solve it in under 90 seconds with a populated variable table. Concept. Along a streamline of a steady, incompressible, inviscid flow, the sum of pressure, velocity, and elevation head is constant. Bernoulli, energy conservation in disguise. Continuity is mass conservation. Area times velocity is preserved. These two are the foundation for the next 5 topics. Darcy-Weisbach, minor losses, pump sizing, pump curves, flow measurement. Here's the math. Bernoulli in head form, pressure over rho g plus v squared over 2g plus z at point 1 equals the same sum at point 2. Each term has units of length, feet of head. Continuity, Q equals area times velocity, preserved between sections. 2 equations, at most 3 unknowns once you've tagged the 2 stations. Setup. The highest leverage move in fluids. Before you write Bernoulli, run a 5-second checklist. 1. Incompressible, a liquid or gas under Mach 0.3. 2. Steady. 3. Inviscid, no friction. 4. Same streamline. 5. No work, pump, turbine, or fan between the points. If any answer is no, drop Bernoulli for the extended energy equation, which adds pump head, turbine head, and head loss terms. Most students apply Bernoulli where it doesn't fit. 5 seconds saves 5 points. Pattern recognition. Bernoulli applies when the stem says frictionless, neglect losses, short pipe, nozzle, contraction, steady, incompressible, or large tank with a small opening. It does not apply for a long pipe with friction, a given head loss value, a pump or turbine, or compressible high-speed gas. You'll see it as water flows steadily from a reservoir through a 4-inch pipe to atmosphere, find V. Bernoulli plus tank discharge. Build the variable table. 2 columns of state, point 1 and point 2. Rows for pressure, velocity, and elevation. Above, a properties block, density, gravity, and the 2 areas. Below, the most important row, a sigma check. Sum the 3 head terms at each point. They must be equal. If not, a unit slipped or a sign flipped. Fix it before you answer. Handbook quick reference. Fluid properties live in Chapter 1. Continuity and Bernoulli sit together on 1 page of Section 3.3. Mark it before exam day. It's the most referenced page in the fluids exam. Reynolds number and Darcy-Weisbach are on the next page for next week. Pump shaft power comes later. Solve Step 1. Run the checklist. Incompressible, yes. Steady, yes. Frictionless, yes. Single streamline, yes. No pump or turbine, yes. All 5 yes. Bernoulli is the right tool, and the pipe is horizontal, so the elevation terms drop out. Step 2. Populate the table. Convert diameters to feet and compute the areas. Then, continuity. V2 equals V1 times the area ratio, 4:1, giving 16. Smaller area, higher velocity, every time. Step 3. Write the full Bernoulli equation. Horizontal, elevation cancels. Inviscid, no head loss term. That leaves pressure head plus velocity head on both sides. Rearrange. P2 equals P1 plus rho over 2 times V1 squared minus V2 squared. Always write the full equation first, then cross out dead terms. That's your audit log. Step 4. Plug in and watch the units. 2 conversions matter. Pressure from PSI to PSF, multiplying by 144, and mass density to slugs, dividing by G sub C. Drop everything in and P2 comes out about 23.4 psi. Step 5. The sigma check. Convert both sides to head units, sum pressure, velocity, and elevation head at each point, and confirm they agree within rounding. If not, a unit slipped or a sign flipped. Find it before you commit. 15 seconds catches the most common error in fluids. Final answer. P2 is 23.4 psi. Pressure dropped about 1.6, and that energy is now velocity head in the 3-inch section, where V quadrupled to 16. Speed trick. Use head form Bernoulli with gamma from the start. No slug conversion, no G sub C, fewer chances to slip. Traps. 5 high-frequency errors. 1. Mixing density rho with specific weight gamma. Pick one form and stay in it. 2. Applying Bernoulli across a pump, turbine, or long frictional pipe. Rerun the checklist, switch to the extended energy equation. 3. Forgetting continuity when the diameter changes. Write Q equals AV first. 4. Assuming V is 0 at a free surface barely larger than the opening. Rule of thumb, tank area at least 10 times the opening. 5. A unit slip-on pressure, PSI versus PSF. Write units beside every term. The sigma check catches the rest. The 80% rule. 3 habits. 1. The 5-second validity checklist before every problem. 2. The sigma check. Head sum at point 1 equals head sum at point 2. 3. Continuity first, Bernoulli second. Q equals AV, pins the unknown velocity, leaving one unknown for Bernoulli. 3 habits, 80% of this topic's questions. Next, Topic 3, Reynolds number, Darcy-Weisbach friction, and the Moody chart. We drop the inviscid assumption and compute head loss from the friction factor, the length over diameter ratio, and the velocity head. Before the next video, rework today's contraction with a 3-foot head loss between sections, a preview of the extended energy equation. PEPrepengine.com/beta. The Bernoulli cheat sheet, the worked problem PDF, and a 5-question mini-quiz are attached to this video. If the course helps you, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.